Hi guys, I'm here hiding in one of the labs because it's the only place I could find to record this. So we're gonna start or continue, I should say, with Venn diagrams. So I'm going to do a couple of examples for you to have a look at. Take notes. You can find them in the book, and then you can get working. So we'll take it from there. And particularly any of you that are at home at the moment, please make sure you send me an email with a screenshot of any doubts or any questions, so I can reply on Notability with a voice note and everything and solve any questions. So let's get going. Okay, here we are. This is example one. This is where they give you a Venn diagram and you have to answer questions. So my universal set is all the pupils in year 7. Set P is the pupils that play the piano. Set V is the students that play the violin. And C is the set of students that play the cello. And that's my Venn diagram. So, how many year 7s play the piano? Well. That would be all the students inside the P circle. So that is going to be 15. I haven't got my pen today. I'm writing with the fingers. A bit annoying. It's going to be 15 plus 4 plus 3. So that's going to be 22. So that's how many students play the piano. It's all the students in the P circle. How many year 7 pupils are there in total? Well, that is just going to be, how many students are there in total? Well, this is going to be 15 plus 4 plus 3 plus 7 plus 12 plus 44. Because those 44 over here are the ones that don't play any instruments, but they are also in year 7, so you're going to count them. Just because they're not very good with instruments doesn't mean they don't exist. So there you go. You add them all up with your calculator, sort it all out. Easy. Next question is, how many of the violin players also play the piano? So we're looking for, in set notation, so we're talking V intersection P. So the ones that play the violin and the piano. Well, you can see, so I'm looking for the overlap. So any overlap between the V and the P circles. And you can see that there are 7 students in there. So the answer is 7, the 4 and the 3. So there you go. How many of the violin players also play the piano? The answer is 7. And the final question, Fred says everyone in year 7 who plays the cello also plays the violin. Is he right or wrong? Well, he is right. Because how many students play the cello? Well, the answer is 10. It's the 3 and the 7. And all those students that play the cello are inside the violin circle. And what we say mathematically is that C is a subset of V that looks like a big C type thing. This means is a subset or is contained in. So all the students that play the cello are also in the violin circle. So C is a subset of V. All the cello players also play the violin. And therefore, Fred is right. Why? Because of this. Because C is a subset of V sorted. Right, guys. And the other kind of question you may get is this one here, where you're giving information and you have to draw it inside a Venn diagram. So, just read the question, get an idea, and take it from there. So there are 30 people in total that took a survey. 16 said they own cars, and 12 said they own bicycles, and 6 said they own neither one of them. So the question is, identify the sets. Well, my sets are going to be the ones that own the car, I'm going to call it C. The ones that own a bicycle, I'm going to call it B. And I need a big box around them so they don't run away. You actually have to draw the box. Now, typically with these things, you have to start with the either the intersection or the people that neither own a car or a bicycle. So the the 6 people that own neither a car or a bicycle go outside there. So that's where they are. And now you have to be really careful, okay? It's really important to bear in mind a couple of things. There are 30 people in total. There are 30 people in total, right? And now, if you pay attention, 16 plus 6 plus 12, there, 16 plus 6 plus 12 is actually more than 30. There's more than 30, but we know there are only 30 people. So why do we get more than 30? Well, that's because of the overlap area here. It's because of this, because we are double counting people that own a car and a bicycle. The people that own both get counted twice, once because they own a car and once because they own a bicycle. So, how many people own both a car and a bicycle? That's the thing you need to figure out. You have to start with the intersection. So, if I add 16 plus 12 plus 6, and I do that, I get 34. But we know there's only 30 people. So those 4 people extra must be the ones I've double counted. So in here there has to be a 4. Those are the people that own both a car and a bicycle. And therefore, now, if 16 people say they own cars, well, I've already counted 4 people there out of those 16. So how many do I have to write in this part of the circle? Well, the answer is 12. Because 12 plus 4, that's the whole circle of people that own cars, that's 16. And if 12 people own bicycles, and I've already counted 4 there, 12 take away 4 is 8. And if you look at the numbers in the Venn diagram, they add up to 30. 6 plus 4 is 10, 12 and 8 is 20, 20 and 10 is 30. So I make sure I haven't double counted anything. If they tell me that there are 30 people in the survey, I can have more than 30 people in the Venn diagram. It is really important that you pay attention to what I've done and how I figure out that the number in the intersection was 4. So I'm going to recap that. I look at all the information they've told me. So 16 people own cars, 12 own bicycles, 6 own neither, and that number comes up to 34. But if I know that I've only got 30 people, that means I've double counted 4, and those are the ones that go in the intersection. So that's all well, this can get a bit more complicated. You can have a triple, 3-circle Venn diagram, but the basics are there. This is what you need to know. We'll take it from there. So best of luck, and I will see you later. Bye.